All right, welcome to another deep dive. Today we're diving into some really cool stuff requested by you, the listeners, a deep dive into the world of Python, specifically essential techniques that every Python enthusiast should know.
Sounds like fun.
Yeah, it is, right. And we've got a great article to guide us here, most used Python techniques. But, we're not just going to read it off. We're going to break it down, explore the hows and whys, and really get to the heart of what makes these techniques so essential.
I like it. Getting into the nitty gritty.
Exactly. It's like having a cheat sheet to Python's greatest hits, but we're going to figure out how to play those hits ourselves.
And hopefully avoid any sour notes along the way.
Exactly. And don't worry, if you're not like a coding guru, you're not alone. I'm right there with you, learning as we go. All right, so first cab off the rank is list comprehension. Expert, what is the deal with this one? What makes it so special?
Well, you can think of it this way. Imagine you're trying to sift through a ton of data, and you only want to pick out specific pieces that meet certain conditions. List comprehension is like having a super efficient filter to do that in a really elegant way.
Oh, okay. So it's all about efficiency and making things look neat and tidy.
Exactly. It's like, condensing multiple lines of code into a single powerful statement.
Gotcha. So the article gives an example about creating a list of squares. Can you walk us through that?
Sure. So let's say you want to create a list containing the squares of numbers from 0 to 9. The traditional way would be to use a loop, but with list comprehension, you can do it in just one line. Squares equals by 2 for x in range 10.
Wow, that's it. One line for all that.
Yeah. Pretty neat, huh? It's basically telling Python, hey, take each number x from 0 to 9, square it, and add it to our new list squares.
So much faster than writing a whole loop. But can you give us like a real-world situation where this would be super useful?
Absolutely. Imagine you're working with a huge database of customer information, and you need to find, say, all customers who live in a specific city. List comprehension would let you do that super fast, like having a laser-focused search tool.
Okay, I'm starting to see the power of this. It's like simplifying those complex tasks and making your code easier to read. All right, next up on our list is Lambda functions. Honestly, these sound a bit mysterious. Can you shed some light on what these tiny functions are all about?
Yeah, think of Lambda functions as like little tools that you can create and use right within your code without needing to define a whole separate function. It's like super convenient.
Like a Swiss Army knife of functions.
Exactly. They're small but mighty. You can use them for a variety of tasks.
Give me like a quick example. When would I actually use a Lambda function?
Okay, let's say you're building a program that needs to calculate sales tax on different items. A Lambda function would let you define that tax calculation quickly without writing a whole separate function for it.
Oh, so I can just create these little Lambda functions on the fly whenever I need them.
Yep, pretty much. They're like little snippets of logic that you can use and reuse within your code.
Okay, that's pretty handy. But the article mentions that they become even more powerful when you combine them with other Python tools, like map, filter, and reduce. Can you tell us a little bit about that?
Absolutely. That's where the real magic of functional programming comes in. These combinations allow you to process data in a very elegant and efficient manner. It's like having a set of specialized tools for data manipulation.
Sounds interesting. I'm definitely going to want to dive deeper into that.
Yeah.
But for now, let's move on to generators, which honestly sound kind of confusing to me. What's the difference between a generator and a regular function?
Imagine you're reading a really long book, and you don't want to carry the whole thing around with you. A generator is like reading it one page at a time. You only load what you need at that moment.
Ah, so it's not creating like a whole list of values at once?
Right? Generators produce values on demand, which is really useful when you're working with huge data sets that could otherwise take up way too much memory.
That's smart. So instead of generating the whole sequence up front, they create values one by one, as needed.
Exactly. It's a technique called lazy evaluation.
Lazy evaluation. Is Python getting lazy on us?
No, not at all. It's a brilliant way to save resources and make your code run more smoothly.
Okay, I'm intrigued. But how would this actually work in practice? Can you give me an example?
Sure. Let's say you wanted to calculate the Fibonacci sequence, but up to a really large number. A regular function would create a giant list, which could use up tons of memory. But with a generator, you can define a function that spits out each Fibonacci number one at a time. Like this. Look. Python.
AB equals 0, 1. For in range, N for in range, and for in range, AB equals B, A plus B.
Okay, break that down for me a little. What's going on in this code?
Well, the magic is in the yield keyword. Instead of returning a single value and ending the function, yield pauses the function, gives you a value, and then picks up where it left off the next time it's called.
Oh, so it's like a pause button for functions.
Exactly. And it's this pause and resume behavior that makes generators so memory efficient, even when dealing with massive sequences.
That's pretty cool. I'm starting to see why these techniques are considered essential. All right, on to number 4, decorators. What kind of coding magic are we talking about here?
You can think of decorators as like giving superpowers to your existing functions. They let you add extra functionality without actually changing the original code.
Adding superpowers. So it's like a secret upgrade then.
Yeah, exactly. It's a really elegant way to enhance your functions without messing with their core logic.
Okay, I'm liking the sound of this already. Can you give me a real-world example of where I might use a decorator?
Let's say you're building a program to fetch data from a website. You could use a decorator to add caching functionality. So if you need the same data again, it's already saved and you don't have to fetch it again.
So it's like a built-in memory booster for your code.
Exactly. It helps your code run faster and more efficiently. And it does it in a very clean way.
But how do decorators actually work? Do they, like, sprinkle magic fairy dust on my functions?
Not exactly fairy dust, but they do involve a bit of Python cleverness. They basically wrap your existing function with another function, adding those extra features before or after the original function runs.
So it's like a function sandwich, with the decorator as the bread and my original function as the filling.
That's a great analogy. And the coolest part is you can apply decorators using the @ symbol, making your code look super clean and easy to read. Here, take a look at this simplified example. Python.defwrapper.defwrapper.print. Something is happening before the function is called. Defwrapper.print.defwrapper.print. Something is happening after the function is called. .defwrapper. .returnWrapper.defwrapper at my decorator.
Say hello. All right, break that down for me a bit.
Sure. So we have a function called sayHello. It's a simple function that just prints hello. But above it, you see the @myDecorator line. That's the decorator at work. It's telling Python to decorate this function with the myDecorator function.
Oh, okay. So then what does my decorator actually do?
Well, it defines a wrapper function, which essentially adds extra actions before and after calling the original sayHello function. In this case, it just prints messages before and after the greeting.
Oh, I see. So when I call say hello, it will print those extra messages too. Exactly. And the beauty of it is the say hello function itself remains untouched. We've enhanced its functionality without directly modifying its code.
That's really cool. I'm definitely starting to feel like I'm leveling up my Python skills here.
Decorators are a powerful tool, and once you get the hang of them, they open up a whole new world of possibilities for customizing your code.
Okay, I am definitely putting decorators on my list of things to practice. All right, moving on to number 5, context managers. This one sounds kind of intriguing. What are we stepping into here?
Context managers are all about creating a controlled environment for your code, especially when you're dealing with resources like files or database connections. They make sure those resources are properly handled and cleaned up, even if errors occur.
So they're like the responsible friend who always makes sure everything's taken care of?
Exactly. They take care of all the setup and cleanup, so you can focus on the important stuff. For example, imagine you're working with a file. You need to open it, read or write data, and then close it properly. A context manager handles all of that for you automatically, closing the file when you're done, even if something goes wrong.
Oh, okay, so it's like a safety net for my code.
Exactly. They're crucial for writing robust and reliable code, especially when external resources are involved.
Makes sense. Can you show us how this actually works in Python?
Sure thing. The with statement is the key to using context managers. Check out this example. .python.with open myfile.txt w as file.pu as file.file.write. Hello world.
Okay, let's break it down. What's going on here?
So the with statement creates a context. Inside that context, the file, myfile.txt, is open for writing and is assigned to the variable file. You can then write data to the file using file.write.
And when the with block ends, the context manager takes over.
Yep, it automatically closes the file for you. No need to do it manually.
That's super convenient and clean. Okay, I'm seeing why context managers are a good practice to adopt.
Absolutely. They help avoid potential problems and make your code more reliable.
All right, we're halfway through our list of essential Python techniques, and I already feel like I've learned a ton.
Yeah, we've covered some really important ground here. It's amazing how these simple but powerful techniques can elevate your Python game.
Definitely. We've got 5 more techniques to explore, but we'll save those for part 2 of our deep dive. Welcome back to our Python adventure. We're ready to dive into the next batch of essential techniques, and I'm particularly curious about regular expressions. I have to admit, they sound a bit intimidating.
Yeah, I get that. Regex, as they're often called, can seem a bit cryptic at first, but trust me, they're incredibly powerful tools for working with text. Think of them as search and replace on steroids.
Okay, that sounds interesting. But how would I use regex in, like, a real-world situation? Give me an example that doesn't involve decoding ancient hieroglyphics.
Imagine you're building a website, and you need to make sure users create strong passwords. You could use regex to enforce rules like the password must contain at least one uppercase letter, one lowercase, and one number. It's like having a security card for your user data.
Ah, so it's not just about finding things, it's also about setting rules and validating information.
Exactly, and Python makes it really easy to work with regular expressions using the re module. Let me show you a quick example. Python.import re pattern equals r plus text. I have 10 cats and 2 dogs. Matches. Needed friend, text, pack, print, matches.
Okay, let's break this down. What's happening here?
First, we import the re module, which gives us all the tools we need for working with regex. Then we define a pattern, ard plus fido, which means find one or more digits. And we have our text, which mentions the number of cats and dogs.
Right, so re.findAll, that's the function that does the actual searching.
You got it. It searches the text for all occurrences of that pattern and returns them in a list. So in this case, the output would be 10, 2.
So it finds all the matches, not just the first one.
Exactly. And that's just scratching the surface of what you can do with regex. You can use it to extract parts of a string, replace text based on complex patterns, and so much more. It's super useful for anyone working with text data.
Okay, I'm convinced regex is going on my list of Python skills to master. It sounds like it can save a lot of time and headaches. All right, next up is dictionary comprehension, which sounds a bit familiar. Is it like list comprehension, but for dictionaries?
You're catching on quick. Yes, it's very similar. Dictionary comprehension lets you create dictionaries in a concise and efficient way, just like list comprehension does for lists.
Okay, I remember how cool list comprehension was. But why not just create dictionaries the regular way? What makes dictionary comprehension so special?
It's all about writing cleaner and more efficient code. Let's say you have a list of words, and you want to create a dictionary where the keys are the words and the values are the lengths of those words. With dictionary comprehension, you can do that in one line. Word lengths, word by land, word for word, in words.
Wow, that's incredibly concise. It's like a tiny dictionary factory.
Exactly. It's especially useful when you're working with data that needs to be transformed or organized into a dictionary.
I'm seeing a trend here. Python is all about making things simple and readable. I like that. Okay, let's move on to technique number 8, zip and unzip. This one sounds a bit strange. Does it involve packing my code into a compressed file?
Not quite, but the analogy is close. In Python, zip is used to combine elements from multiple iterable objects like lists or tuples into a single iterator of tuples. It's like pairing up items from different bags.
Pairing things up. Okay, but what makes that so useful in Python?
Think of it like this. You have a list of student names and another list of their grades. Zip lets you combine those lists into pairs, so you have Alice paired with her grade, Bob with his grade, and so on. This is super helpful for working with related data.
Ah, so it's about creating connections between different data points.
Precisely. And unzipping is just the reverse, separating those paired elements back into their original lists. Here's a simple example. Python, names, Alice, Bob, Charlie. Scores equals 95, 88, 76. Zipped. Zip names, scores. Print, list.
All right, what's happening in this code?
We have our lists of names and scores. The zip name scores line combines them, creating an iterator of tuples. Then we convert that iterator into a list so we can see the result. A list of name score pairs like this. Alice 95, Bob 88, Charlie 76.
Oh, I see. So it's like a temporary partnership between the two lists. And if we need to unzip them back into separate lists, we can use the zipped trick.
Exactly. It's a simple but powerful technique for working with related data.
Definitely seems like a handy tool to have in your Python arsenal. Okay, moving on to technique number 9, F-strings for string formatting. This one sounds a little less intimidating. Is it just about making my strings look pretty?
It's about making them pretty efficient and readable. F-strings, introduced in Python 3.6, revolutionize the way we format strings. They allow you to embed variables and expressions directly into your strings.
Okay, give me an example. How would I use an F-string to, spice up my strings?
Let's say you have a variable called name, and you want to greet the user with a personalized message. With an F-string, it's as simple as this. print. F, hello.
Wait, really? I just put the variable name in curly braces inside the string?
Yep, that's all it takes. Python will automatically replace those curly braces with the value of the variable. So if name is Alice, the output would be hello, Alice.
That's way cleaner than the old ways of formatting strings. I love how simple and intuitive it is.
Right. F strings make your code so much more readable and easier to maintain. They're used everywhere for things like logging, reports, and web content.
All right, F strings are definitely going on my list of favorite Python features. Okay, we've reached the final technique on our list. Error handling. Try except. This sounds like it's about saving my code from crashing and burning.
You got it. No matter how good you are at coding, there's always a chance of unexpected errors, like trying to open a file that doesn't exist or dividing by zero. Error handling is how we deal with these situations gracefully and prevent those nasty crashes.
So try except blocks are like safety nets for our code.
Exactly. The try block contains the code that might cause an error, and the except block tells Python what to do if that error actually happens. It's like having a backup plan.
Makes sense. Can you give me a real-world scenario where error handling would be crucial?
Imagine you're building a program that takes input from a user. You can't always be sure they'll enter the right type of data. They might type text when you're expecting a number, or accidentally try to divide by zero. Error handling lets you catch these mistakes and give the user a helpful message instead of crashing the whole program.
So it's about creating a more robust and user-friendly experience.
Exactly. Error handling is essential for writing reliable, professional code. Let's look at a quick example. Python.num1 equals input, enter a number. That num equals input, enter another number. Input, enter another number. Result equals num1, num2. Print. The result is dot result. Print. Error. You cannot divide by zero. Print. Error. Please enter valid numbers.
Okay, walk me through this code.
This code asks the user to enter two numbers and then tries to divide them. The try block contains the code that might cause problems, like if the user enters invalid input or tries to divide by zero.
And the except blocks are our error handlers, right?
Exactly. We have two different except blocks here. The first one handles zero division error, which happens if someone tries to divide by zero. The second one handles value error, which would occur if the user typed in something that's not a valid number.
So instead of crashing, the program will give a helpful error message.
Precisely. It's a much better user experience and helps prevent unexpected crashes.
All right, we've officially covered all 10 essential Python techniques. I'm feeling a bit overwhelmed with all this new knowledge, but in a good way.
It's a lot to take in, but you're doing great. We've covered some incredibly powerful tools that can really level up your Python skills.
Before we officially wrap up this Python deep dive, let's take a moment to reflect on everything we've learned. We'll be back in just a moment to discuss some key takeaways and see what other Python adventures await. All right, welcome back for the final part of our Python Techniques deep dive. Whew, my brain is still buzzing from all those amazing tools we've explored. I'm excited to see what we can build with them now.
It is pretty remarkable how much power Python packs into those techniques.
Yeah, absolutely. So, expert, before we officially wrap things up, I wanted to ask you, out of all the techniques we've covered, which ones were the most impressive to you?
That's a tough one. They all have their own strengths and uses, but if I had to pick a couple, I'd say generators and decorators really blew me away. The way generators can handle huge amounts of data so efficiently is like mind-blowing, and decorators just add this elegance and extra functionality to your code that I love.
I totally agree with you on those. Generators were definitely a game changer for me too, realizing you don't have to load everything into memory at once. And decorators, yeah, they're like those silent ninjas working behind the scenes, making everything run smoother and better.
It's like unlocking hidden potential within the language itself.
Right. In this article, Most Used Python Techniques, it was a goldmine of information, but it did mention that these are just like the foundational techniques. What lies beyond this, expert? What other Python wonders are waiting for us out there if we keep exploring?
Oh, there's a whole universe of Python goodness to discover. Once you have these basics down, you can really start digging into more specialized areas like object-oriented programming, data structures, algorithms, and there's a whole world of Python libraries to explore.
Libraries. What are those exactly?
Think of libraries as like pre-built toolkits for specific tasks. There are libraries for data analysis, machine learning, web development, scientific computing, you name it. There's probably a library for it.
So it's like having access to a whole team of expert coders who've already done a bunch of the work for you.
Exactly. It's one of the things that makes Python so versatile and powerful. The Python community is super active, and they're always creating new libraries, so there's really no limit to what you can do.
This is getting me so pumped to continue my Python journey. I can already see so many possibilities opening up.
And that's the beauty of it. Python is a language that's constantly evolving, and there's always something new to learn and explore. It's an exciting world to be a part of.
Well said. All right, to everyone listening, whether you're a seasoned coder or just starting out, remember, every Python expert was once a beginner. So don't be afraid to experiment, have fun, and see what amazing things you can create with this incredible language.
Absolutely. And remember, the Python community is always there to help. Don't hesitate to reach out, ask questions, and connect with other Python enthusiasts. It's a wonderfully supportive and inspiring community to be a part of.
That's such a great reminder. Thanks for joining us on this Python deep dive, everyone. Until next time, keep coding, keep learning, and keep pushing the boundaries of what's possible with Python.